Why does system engineering matters to address the new industry challenges? This is a key question. The world we live in is a system of systems, where smarter and sophisticated products are connected together to enable new customer and new end-user experience. The transformation from product to experience must also take into account the challenges of sustainable development and new business model, more resilient. In these sessions, we will see how the model-based system engineering approach is a catalyst for these industry transformations. By addressing these questions, 1. Why is a system approach becoming necessary to solve societal business challenges? 2. What is the state of the art in the adoption of the MBSE approach by different industry sectors? 3. What is the strategy of what Dassault Systèmes and CATIA solution for MBSE adoption with the digital twins? On the challenges side, products are so complex that traditional methods and skills do not work. Data analytics are critical to better understand the real-world data and use them as insight in the virtual world to continuously improve design and engineering. To get feedback from the virtual and real test, most engineers are still working in silos, and multidiscipline engineering is key to fail fast and converge earlier. So what does the future engineering look like? To support the transformation from product to experience, the challenge is to empower engineers with solutions to design, simulate, and optimize the best system of systems from mission to certification-driven simulations. What are the potential strategy and solutions? What is system engineering about, by the way? When building our strategy at CATIA, we had to start from what the industry defined as a reference framework. Today, the traditional V model is still one of the most known and used frameworks. In the illustration on the screen, I took one example from Audi inspired by the Incosi System Engineering Handbook. Our approach is based on 4 transformation axes to cover this V model end-to-end and transform it. Let's discover them and see how they are answering the nowadays challenges of the industry. Pillar number 1, from mission engineering to system architecture, modeling and simulations. CATIA provides the capacity to model and simulate requirement architecture in the early phase of a program for engineers and program leaders to collaboratively make the best trade-off specifications can be captured in model with the right level of semantics, enabling early detections of errors and inconsistency. Model can be reused and shared by different stakeholders. For example, if a new automated driving feature is specified, what would be the impact on the safety assessment? Should we add redundant sensors? How would this impact safety, performance, and cost objective? Pillar number 2, to continuous multidiscipline automation integrations. We want to perform continuous multidiscipline automation and integration, optimizing the mechanical, electrical, and software discipline. Pillar number 3, to massive simulations of user experience. Third, we want to allow massive simulation of user experience. For example, as soon as a new automated driving functionality has been specified by the system architect, it can be tested in a virtual and realistic environment. The driving data from the real world can be collected and analyzed to enrich the testing scenario. This continuous and massive simulation enables you to identify and validate edge causes. Last but not least, governance and openness allows full process continuity and traceability to comply with standards and regulations. System engineering defects, with their lifecycle configuration and change, can be managed during the development process. To illustrate my presentation, I like to use a case study. This case study concerns energy management in transport and mobility. It is a system of systems. Indeed, in this use case, you have to deal with end-to-end lifecycle. And the system of systems concerns energy management, where you need to take care of the different subsystems, like the chassis, the powertrain, the battery, the propulsion system. And you have to look to the KPI like the range, the lifespan, the CO2 emission, the charging time. To conclude, I like to speak about adoptions. I mean MBSE adoption across industry, and for that, I'm going to use customer testimony from Airbus, Safran, EDF, Bosch, Renault. Airbus, it's about an end-to-end process from MBSE to multidiscipline. Safran, it's about performance-driven modeling simulation for sustainable aircraft engine. EDF, this is requirement simulation and validations for mission and safety critical system. Bosch, about software-defined innovations. And Renault, about massive simulations for highly automated system of systems. Thank you.